This is Unit 6 in Integrated Math 1. We're doing proving parallel lines, special angles. Go ahead and put in Ernest-D. Oops, if you haven't already, put in Ernest-D in your block. This sheet pretty much will tell us what we are doing for the unit, section by section. I will tell you at the end of 6.1, you do have the practice on pages 6. I believe it's 6 and 7, but it might just be 6. All right, so we're going to jump right in. We have a little bit of a review from the geometry unit, unit 2, I believe, or unit 2. And then we're going to talk about parallel lines cut by a transversal. So starting out solving for B, well, hopefully you guys remember that this straight line is 180. So B plus the 50 is going to equal 180. So B plus 50 equals 180, and we go ahead and solve that. We end up with B is equal to 130. This other one, these are actually called vertical angles. So this is a linear pair, adds to 180. This is vertical angles. They are congruent. So that means I can set them equal to each other. So 6x minus 45 is equal to 4x plus 5. Minus the 4x on both sides. Add 45 to both sides. So now we have it tidied up a little bit better, and we have 2x is equal to 50. So x is equal to 25, which is great. I do want you to find the angle measure though. So go ahead and plug that back in. We're going to say 4 times 25 plus 5, which is 100, plus 5, which is 105. Now, normally I would say, okay, you're done. However, let's double check to make sure that we're correct. Let's go ahead and plug it in over here for this x as well. So 6 times 25 minus 45. Well, 6 quarters would be $1.50, so 150 minus 45 gives me 105 degrees. So it does work, so I am correct. All right, looking down here into the vocabulary, parallel lines. Parallel lines intersect, parallel lines don't intersect. In other words, they don't cross. The symbol for parallel is these two little sticks. Now, given that A is parallel to B, so let's do this, A and B. If they're parallel, we can mark them with extra little arrows. So we can say, we can say little arrows like that. That will say that they are parallel, so matching arrows. Now, skew lines are non-coplanar lines that do not intersect. Parallel planes, but that would be kind of like the ceiling and the floor. Those are going to be parallel. So if I were to have, like, here's the ceiling, and this is the floor, they're not going to intersect. Okay, so planes that do not intersect. Perpendicular lines, however, two lines that do intersect to form a right, which is a 90-degree angle. Now, if I have A as perpendicular to B, if they're perpendicular, we're going to mark it with this little box. Oops, let's call it a right angle box. Let's undo that. Right angle box. I got a little ahead of myself there. All right, so then those next two are just like some postulates. We'll actually go over this more with the constructions. Use with our constructions, a concept of parallel and perpendicular. Basically is saying through, if I have this point and I have another line that goes through it that does not touch the other line, they're going to be parallel. Likewise, if I have a point and the line goes through it and it makes a 90-degree angle, it's perpendicular. Alrighty, so here we are. We're going to jump right in with some information about parallel lines, etc., and skew lines. So let's use that vocabulary. Parallel lines, RU. Well, if this is RU right here, I want to contain point S, it's going to have to be ST. Now, if I have skew lines to RU, here's RU. So I cannot use anything that would be here or here because they can't be on the same plane. And RU is on both of those two planes. So all other pieces we could use. So skew to it would be, let's start here, I would say SX. I could say TY. I could say WX. I can say ZY. And there's one more, I believe, back here in this back area, XY. So now I want lines that are perpendicular to RU. Well, here's RU again. Perpendicular means it makes a 90 degree. So this would make a 90. This would make a 90. So I can say, what is that, VT? No, UT, is that a U? UT. UT is going to be perpendicular. UZ is going to be perpendicular. RW and RS. Plane parallel to RST. Planes parallel to RST. Well, if I were to look at RST, let's go ahead and do black. RST. Let's keep the order, please. So it's going to be W. Actually, let's undo that real quick. Let's do plane W. X, Y. So we're basically going in the same direction as what they said before. All right, then we get down here, naming parts of lines that appear, pairs of lines that appear to be perpendicular. Well, perpendicular would be 90 degree. So things that appear to be at 90 degree, I'm going to use this top piece as my, like, this whole thing as CN. So we're going to say CN is perpendicular to what? Well, I would say to this DH. I would say to EI. I would say to EJ or FJ. I would say to GI. Those are all lines, 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 lines. All right. Then I also have these guys right here. So HI is perpendicular to DH, and HI is perpendicular to EF, no, EI. And then we have over here, one more little segment here. We have JK. So JK is perpendicular to what? And JK is perpendicular to what? Well, we have one FJ. And we have GI. Now, we kind of included that already because we said CN up here, and that's the whole thing. Now, I would say that we have some parallels in here as well. So here, which one's assumed to be parallel? Well, parallel, we would have that CN is parallel to HI. CN is parallel to the JI, or JK, excuse me. It appears to be parallel with AB. And seems to be parallel to LM, but we don't know that for sure because they're not really on the same plane because they're on separate things. So I'm going to really stick with and then I'm going to say that, yeah, that's pretty much it. Next one, perpendicular to LM. Well, LM is DH. DH is that perpendicular to LM. They're not on the same plane, so no. Alrighty, transversals. Now this is the meat and the potatoes of the whole entire unit. Here's where we're starting. We're talking about a transversal. Well, if I have this line right here, and I've got this blue line down here, and let's get this guy to be a red line. Oops, let's undo him real quick. There we go. That red line is the transversal. Okay, it crosses a line that crosses or intersects two or more coplanar lines at different points. So that red line is my transversal. Now, thinking about that transversal, okay, so here's my transversal. We're going to do alternate interior angles. Well, I'm going to be talking about inside. So basically, when I say inside, I mean inside the green line and the blue line, per se. So alternate means different sides. Alternate sides, right? One on one side, one on the other side, or diagonal. And interior means between, in between the two lines. So I could say 3 and 6. And I could say 4 and 5. Or alternate interior angles. Then I go over here on the next page. I want alternate exterior. So that alternate means different sides. And diagonal. Exterior means out. Oops. Outside the two lines. So here are my lines with my transversal. I want a diagonal outside the two lines. So like 1 and angle 8. I would say angle 2 and angle 7. Diagonal and outside the two lines. Now the next piece, again, here's my, oops, I should make that red. Here's my transversal. Corresponding means in the same location. Angles in the same location, such as upper right, upper left, lower right, lower left. But keep in mind, you're really looking at kind of, let me get a highlighter here. We're kind of looking at this set and this set. Oops. Because those are kind of like clusters. So given those clusters of numbers, we're running corresponding. So if I'm upper left, so angle 1, and angle upper left would be angle 5. If I said upper right, so angle 2, and angle upper right would be 6. If I said lower left, so angle 3 is going to go with angle 7. And if I did lower right, I'm going to have angle 4 and angle 8. Those are going to be corresponding in the same location. Okay, the next piece we have is same side, so we're on the same side. Interior means between the two lines. Same side in between the two lines, and I want consecutive. So in a row. Now you can either call it same side interior angles or you can call it consecutive interior angles. They are one and the same. So here's my little red line. Same side interior. So here's in between. This is going to be in between. Or we're looking at these guys. So the ones that are on the same side would be like 3 and 5. Or angles 4 and angle 6. All right, so now you have all the information. We're going to just have you guys go ahead and try. So pause me, try example 1 and example 2. Keep in mind that we want to pair with angle 4. So here's angle 4 right here. Here is my transversal. So then go ahead and answer such questions. Pause me. All right, so example 1, same side consecutive interior angles. So same side consecutive. So it would be 4 and angle 6. Alternate interior means opposite sides or diagonal of 4. Diagonal from 4 is going to be angle 5. Corresponding angles, meaning the same location. Corresponding, same location for 4 is going to end up being its lower right. So this is going to be lower right. Is going to be angle 8. And now I'm going to ask you the type of angle pair for angle 3 and 7. So 3 and 7, they are corresponding angles. 2 and 7. 2 and 7 are going to be alternates on opposite side of they're diagonal, but they're alternate exterior angles. They're outside. And the last example 2 down here, I just wanted you to look at it and try to see. So angle 1 and angle 12. So basically here are my lines. And this is my transversal. So these are going to be alternate exterior. They're outside of the two lines, so they're going to be alternate exterior angles. And then if I do 2 and 9, 2 and 9, they're on the same side and they're inside those two angles, or those two lines. So they're going to be same side interior angles, or CIA. 3 and 7, they're in the same location, right? This cluster and this cluster, same location. So they're going to be corresponding angles. And 8 and 13. Here's 8 and 13. They're between these two lines, and they're on the opposite sides of the transversal, so they're diagonal from one another. So they're alternate interior angles. Your assignment is the next page.